Welcome to the ICIST webinar, Making R Interactive with Shiny. This is Wei Yin, this webinar's moderator, one of the co-chairs of the Professional Development Committee of ICIST. We have another co-chair, Sarah Young, who's sick today, so she cannot be at the front end, but Sarah is now supporting us at the background. So Sarah, thank you, and hope you can get recovered very soon. Before I introduce today's webinar presenter, I'd like to say many thanks to Michelle Hesley, the Numeric Data Services and Data Management Librarian at University of North Carolina at Chapel Hill, who proposed this wonderful webinar and helped it happen today. And now, let me introduce you today's webinar presenter, Michelle's colleague, Lorin Bruckner, the Data Visualization Services Librarian at University of North Carolina at Chapel Hill. Lorin has worked as a Data Visualization Librarian at UNC Chapel Hill since 2016 while assisting researchers at the University Library. She relies on her knowledge and experience in data analysis, as well as her 10-year background in web design and creative direction. She obtained her MS in Information Science at the University of Illinois at Urbana-Champaign. In today's webinar, Lorin will demonstrate the different ways that our Shiny apps have been used in her library, including for patrons, projects, tutorials, and for interdepartmental library statistics. She will review the code used to generate an app and explain how our Shiny works differently from R, the language itself, or the software itself. She will talk about the user interface versus server code and how apps can be improved with some knowledge of HTML and CSS. If you have any questions and comments during Lorin's demo, feel free to send them in the chat box or unmute yourself, just ask directly. Lorin will answer you when she finds an appropriate opportunity. And I will also help with passing along your questions and comments to Lorin if needed. And Lorin, if you are ready, it's all yours.
All right, thank you so much for that introduction, and thank you everyone for joining us today. As Wei said, we're going to talk about our Shiny, and we're going to do that by taking a look at a few use cases. I use our Shiny fairly regularly in my role at UNC, and I use it in different ways. So we're going to discuss a patron project, a project for internally within my department, and also a project that was part of a tutorial for a workshop series. So starting out with this patron project. So this patron is a researcher at the archaeology school, and she was working on a paper that is taking a look at the impact of Robert Schulier's work in the field. So he wrote a very influential paper called Archaeological Perspectives on Ethnicity in America. And she wanted to be able to visualize that impact and that influence. And so basically what we were looking at was creating a citation network. Okay, so we're using a network diagram in this case, which is a series of nodes representing different works. So these little circles that you'll see in the diagram represent different works. And then we have lines, which are links in between those works, and each of those lines represents a citation. And so we got this bibliographic information from Google Scholar, and we basically got information for all works that cited the main text, and then all works that cited those works, and that formed our network. Why did we decide to use our Shiny for this? Well, there are a lot of other network visualization tools out there, but this network was really big. This was a very influential paper. And so it was too difficult to visualize this network well in a tool like Gephi, which is going to draw the network for you statically, right? So in Gephi, we have something that looks like this. And as you can see, you know, with the labels on the nodes and everything like that, it's impossible to understand and impossible to interpret. So what we decided that we needed some level of interactivity where the user can explore certain areas and isolate certain areas of the network without seeing the every detail of it all at once. And another reason that we decided to use our Shiny in this case was that our Shiny actually has a package that works with it that strictly is for creating these network diagrams called Network D3. And it produces these really nice animated interactive graphs. So we're going to go ahead and take a look at this app. It might take a second to load because we're on Zoom, and like I said, the network is rather large. So we'll just give it a second here. Yeah, Zoom is slowing it down quite a bit. But here you can see this is the part that's being produced by the Network D3 package. And when I roll over a node, it might take a second there, it highlights only the direct connections to that node. So it makes it easier to explore this network. This node here, the orange one, is the original text that we're studying. And when I click on this text, or sorry, this node, just giving it a second here because, wow, yeah, it was not working this slowly earlier. I'm pretty sure Zoom is responsible for that. But when I click on this text, or click on the node, we get the text. We get the title of the text, when it was published, and the author. So we've got some bibliographic information here. And then we also have a link to the DOI so we can view the work if we have access to it. Then the other part of this Shiny app are the interactive controls that we have up here at the top. So we can use things like these radio buttons, like drop-down menus and sliders to change what we're looking at down below. So for example, I explained how we were looking at basically a distance of 3, which means we have the works that cite this work, and then all of the works that cite those works. And it's a lot to look at all at once. Maybe we just want to look at the first level of citations down here, and that gives us a much smaller network, and so we can focus in on these things. That's how these filters can help us here. We can also use, I've added a menu here for changing how the size of these nodes work and what the size symbolizes, right? So right now, the size of the node is symbolizing something called betweenness. We also have some other options such as distance and degree, and these terms might be pretty foreign to somebody who doesn't do a lot of work in network analysis. And I understood that this audience probably didn't have a lot of experience with network analysis. So we have down here these definitions that I added. We can change the size of the nodes. We can also take a look at doing some filtering here. So let's say we want to only look at certain years of works, maybe within the first couple of decades after the original work was published. We can do that using this filter. You notice how the network redraws itself each time I move this slider, and we'll get an idea for why that is when we take a look at the code, which is what we're going to do next. So how is this working? Basically, our Shiny apps have 2 main components to the code. You have what is the user interface, or the UI code, and then you have the server code. And so here's an example of how the user interface works. We use this function Shiny UI that comes with the Shiny package. And that tells R that we're building a user interface. We're building a Shiny interface. And anything we put inside Shiny UI is going to be part of that interface. Usually, the first thing inside of that interface is something we call a fluid page. A fluid page is just responsive. It's a responsive web design element, so that when you resize the window of a browser, it's going to resize the page. And then if you have a background in web design, it really does help with Shiny, because you sort of have this intuition as to how we build these layouts. We have boxes. Those boxes can go inside other boxes. They can exist in rows and in columns. And so we can add, Shiny allows us to add those different layout components to the interface. For example, the title panel function that you see here, this corresponds with this title panel up at the top. It's one big row up at the top. We also have a row that has multiple columns in it. Here's all the little columns in this row at the top, and each of those columns has a different control. Okay, so this is how we lay out where things go on the page. And by the way, all the code that I'm including in the presentation today, this is very much condensed. I've removed a lot of it. I removed a lot of the parameters and things like that, so it's easier to read and understand. So just keep in mind that this is a condensed version of the actual code that's used for this app. So here you can see where the controls come in. And these are called input controls because the user provides input through them. And each of them every input control needs some sort of input ID. Some way of giving a name to that specific piece of input. For example, the slider for years has an input ID of year. Then we get to our output elements. So output elements respond to the user's input. And in this case, in the user interface, we don't yet tell Shiny how to respond to the user input. That's done on the server side, but we do simply place it in the interface. It determines where that output is going to exist. And notice we also have output IDs. So the whole idea behind having these input IDs and output IDs is that when we get into the server code, then we can reference those IDs. And that's how these different elements in the UI and in the server are able to interact with each other. So for example, this is just a small part of the server code specifically related to the network diagram itself. Okay, so you can see again, we have this function that tells Shiny, okay, here's the code for the server. And every time we use this function, we also want to have a function that indicates the input and output parameters for using those input and output IDs. This is, for example, what the output ID looked like on the server side. We have an output object, and part of that object is net, which corresponds with the output ID for the network. Okay, so for this output object, we're rendering a force network. Okay, so that render force network, that comes from the network D3 package, that package that I added to Shiny that allows me to draw these networks and is meant to work with our Shiny. Here we have an example data frame, and here we've got an idea of how we would filter this data frame based on the inputs, right? So one of the inputs that we had was year, and that input was a slider. If we remember, that slider had two different parts to it. It had a beginning and an end, right? So here we're filtering the database between the beginning year and the end year. And then we draw the network, and then that gets rendered here in the interface. So that's essentially how a Shiny app works in R. You'll notice a lot of similarities to your base R code or tidyverse code or things like that, but ultimately it comes down to these input and output objects. And then finally, the app needed to be deployed. And we have a number of different options for how to deploy Shiny apps. In this case, The app that we were created is meant to be shown to the public. It's open to the public. There's the data is available to the public. So we deployed it on shinyapps.io. Shinyapps.io is a free deployment service, hosting service that what was previously called RStudio, but is now called Posit. Posit provides this service. It is on secure servers with encryption, and they do not own the rights to any of the apps or the data that you put on their server. I've noticed that's pretty much a trend for a lot of these companies that provide sort of this free hosting of apps that use their tools. And the idea behind that is they don't want to be held liable for you releasing private information or releasing data with a license that you weren't supposed to release. And so you're held liable for that, and they don't own your data or your information. Any questions about this first demonstration, this first project? I'll give just a few seconds and then keep going on. And like I said, I don't mind if you type things into the chat, or even if you speak up on the mic or anything like that. I have no problem with being interrupted. I don't think it's rude. It doesn't bother me. All right, in that case, I'm gonna move on. So the next use case we're talking about here was internal, specifically for the department. Digital Research Services is the department that I work within at the libraries. And our department, we provide a lot of consultations, lots and lots of consultations. And each of these consultations has an intake form. So a patron will fill out a form with their information, asking for a consultation. And then once the consultation is over, then we are required to also record information about the consultation to keep records and to document that information. Now, this was primarily done manually for a very long time. Before I joined and after I joined UNC, we would spend hours entering in what we called our stats, which is the information about these consultations. We often didn't have time to enter the information right after the consult. So they would, all of our consults would build up. And at, whenever our department head needed to run a report on our stats, we would all spend a few hours, sometimes even a day, depending on how long we waited, entering in those stats. And this was really a frustrating problem because we were using both of the tools that we used to both get information from the patrons and then put information, put the stats into the database. Those were both tools provided by LibApps. So we were using LibCal to get information from the patrons, and then we were using LibInsight to record information about our consults. And those tools, we could not get them to talk to each other. This, it's likely possible to have a setup in which those two tools do talk to each other. I'm sure with different licenses and different versions of LibInsight, I know that there's an option for an API for things like that. However, we don't have control over our license with LibApps in our department. That all that information was handled by somebody else. And so we just had no option of getting these two different forms to line up with each other to share the information from one database to the next, or from one app to the next, from LibCal to LibInsight. And the reason that I thought Shiny would be a good way to solve this problem is because Shiny has those input controls and output controls. And one of the inputs is for uploading a file, okay? And when you upload a file into R, you can then do data transformations to that file. And then you can provide an output control in Shiny for downloading a file. Okay, so LibCal gives us the option to download information, a spreadsheet of information, CSV file, about all of our consultations that we've had, download that in a spreadsheet. And then we can also upload a spreadsheet into LibInsight about all of our consultations. But those two spreadsheets have to be formatted very differently. You can't just take one from LibCal and upload it into LibInsight. We have to make some transformations to the data. And so I decided to create a Shiny app that would do that. And I'll just do a quick demonstration of how this app works. This app is going to be very different because in this case, we don't just have one place where for people to look at things and click on things. This is a process. We have to do things procedurally. We have to do things step by step. So I want to upload some appointments that are from LibCal. And I have my first step here that tells me how I can get that appointment information, how I can select the dates for the appointments that I want information on, and then how I can export a spreadsheet file that has that information. Okay. And then the next thing I do, once I've exported that file, I've got that file, I'm going to put in my name. So I'll just put in my name here. And here is that upload button that I was telling you about, that input control. So this lets me go ahead and do something directly off of my computer. I'm just going to pick, a file to demonstrate here. And here's the next issue that we had with this process. So we have this intake form for consultations. Every staff member has a different intake form where they create their own questions for that intake form. So when you look at, for example, asking a patron about their status, that could mean their academic status, and then that information would go here in the LibInsight form for patron type, right? So these pieces of information can have different names. It could be called academic status, it could be called patron type, and we need a way to bring that all together. And so the way that I managed to do that was by using a drag and drop tool. And then I'll talk more about it, but it did come from a third party, a package that I added to RShiny. So here I'm going to go to status. This is the question that asks about their academic status. And I'm going to put that in patron type. Put department in department, and then I'm going to try, this one goes into additional information. And then I'm going to say submit. Okay, so now that I've finished step 3, I can go on to step 4. And then I can click on this download button, and it's going to let me download, choose where to put this file to download. And that is the file that I'm then going to upload into LibInsight. So overall, what this process takes is about 5-10 minutes at most, compared to the hours that we used to spend entering in our stats. There we go. So how were we able to make that work? So this is a case that since we're doing things one step at a time, we have to move in a process. The validation tools that RShiny comes with are really helpful. We have this function called validate that we use on the server part of our code. And it's really simple to use. We provide needs to this validation function. If those needs are not met, if they're not satisfied, then the app doesn't continue. It won't continue until these needs are satisfied. So for example, if someone hasn't put something in this input field for their first name, it'll say, please enter your first name before we can move forward. We can check to see if it's a CSV file. Here I'm just looking at the last 3 letters of the file name to make sure it's a CSV file, right? Now, the great thing about this too is I wanted to do something more than just checking to see if it was a CSV file. I wanted to make sure it wasn't just any CSV file. It needed to be a CSV file that actually came from LibCal. And so what you can do with the validate function is actually add your own functions into it. You can write your own functions. So this one is called validate CSV. And this function checks the number of columns, it checks the column names. And then if it doesn't feel like this satisfies the requirements for being the right kind of CSV file, it will give you the error message. Also, we had the issue with only wanting to show certain steps at a time and moving to different steps as we proceeded through. And that was really easy to do on the interface portion by using this thing called a conditional panel. So these are panels that won't show in the interface until a condition is met. This condition here in this example being that the user submitted a file. Once they submit a file and the file is validated, then we can go to the next step, where we have, all the information for the next step that's in rows and columns and text boxes and so forth. And then finally, those inputs and outputs that I showed you for files, again, those were also very, very easy to add. It's a file input button, just like any other input element that you can add in R Shiny. You need to give it an input ID, you give it a label, and then you tell it what it's going to accept. So here we can specifically say, I only want to accept CSV files. The only thing is it doesn't give you a validation message here. If you don't give it a CSV file, it just grays it out, where it won't accept anything other than CSVs. So that's why validation was also necessary in that case. And then finally, the download button, again, super simple. Just an output ID and you're good. The dragging and dropping, so that came through, again, through another third-party package called Sortable. Sortable allows you to create objects that can be dragged and dropped. And also you can do a lot of other fancy things with them that I didn't need to do, like sorting them and ranking them and things like that. And this, again, this is another one of those third-party packages that was developed in JavaScript originally before it was made for R Shiny. That tends to be a case with I might even say the majority of packages that work with R Shiny. Lots of JavaScript involved. So maybe if you're familiar with something that works in JavaScript, you might be able to find it in R Shiny as well. And this, to deploy this one, we did not want to deploy this on shinyapps.io because we didn't want to make it, publicly available. We wanted this to be an internal, private thing. I will also say that shinyapps.io has a limit on the number of apps that you can deploy. So that limit is 5 with their free plan. There's other plans that allow you to deploy more apps, and also ones that will allow you to set permissions and have usernames and passwords and things like that. But we thought it would be a better option to deploy something called Shiny Server on our own server here at the library. And someone in IT was kind enough to set that up for me. I also know that that's secure. I don't have a lot of information about that. Unfortunately, it's a little bit out of my wheelhouse, but it works very well for us. It works also in that, you can't, it's secure in that you have to be connected to a VPN if you're off campus and things like that. So there's some additional security measures there. Any questions about this one? I'm glad it looks useful to people, and I'm happy also to answer questions by email if at some point you're interested in implementing something like this.
Hi, Lorin. I think it's very engaged, so everyone is quiet. But I have a quick question. You mentioned the I/O is public, so free for 5 GB. And is this Shiny server also free, or this is kind of the IT service by your institution?
Great question. So yeah, so the server, the hardware is owned by the school, bought and paid for by the school, and administered by the institution. But the software to put on the server is free. to make Shiny compatible with the server is free. You can download it again off the POSIT website, and there's some some information and documentation on how to use it as well. And yeah, I'm glad people think that this would be helpful for them. I was never really sure how difficult other people found it to work within LibApps and use data from LibApps, and if it was really something that was unique to our institution, or if this is just a general problem. But it's unfortunate that those apps aren't easier to get to work with each other. All right. Would it go on a Linux server, or will other server OSs work? I know it will go on a Linux server, and I know that in their documentation they do mention some other platforms. I could not tell you off the top of my head what those platforms are. So the final project that I wanted to show you today is a tutorial for creating interactive visualization dashboards in R Shiny. And I developed this for a weekly workshop series we have, and the website that goes with that workshop. That workshop we offer about, at this point, we only offer 5 different lessons to get you started in R. And so they have to be very general lessons that don't get into specific use cases. But then in addition to that, we have extras that people can work through on their own if they're interested in specific things like mapping in GIS, or text analysis, or in this case, interactive visualizations. And so the data for this particular dashboard comes from Kaggle.com. If you're not familiar with Kaggle, I highly recommend it as a source of sometimes serious and sometimes not so serious free data sets, free and open data sets. Basically, anyone can upload a data set to Kaggle, including this individual known as the Ramen Raider, who has a website where he's reviewed over 2,500 different types of ramen. But the reason that I decided to go with his data set is because it had a good variety of different data types. One thing I can say as a data visualization librarian, after doing this for a while, it's just really hard to make interesting and innovative visualizations when you only have a single type of data. I wanted something that was going to give me multiple types, like categorical data, numeric data, geographic data, to create a dashboard from. So you have something that's a lot more interesting and engaging. So taking a look at this one real quick. So the idea here is that we have average ratings for each brand of ramen. We also have average ratings for ramen coming from different countries around the world on a map. And then down below, we have a table that gives us the brand and variety name and style and country and rating of all these different types of ramen. And then up at the top, we have these controls that will affect all the visualizations below. So for example, if I want to just look at only cup ramen, this is going to filter all of my visualizations. So now I can see the top 20 brands for cup ramen. And I can see which of these countries on the map have the highest rating, and look at the types of cup ramen down here in this table. And it's good to point out also that the map and the table are interactive. So I can zoom in and zoom out here. The table I can search and paginate through and things like that. Now I believe this table does, I don't think it's a third-party app. I might be wrong with that, but I think it does come with R Shiny, whereas this map comes from a package called Leaflet, which I will talk about here. So Leaflet, again, this is another one of those packages that was originally developed for JavaScript. And it was developed a really long time ago, and it's one of the most popular ways of adding interactive maps to a web application. A lot of people really like Leaflet. I really like Leaflet. And you'll start to find that as you use Shiny more often, and especially as you start to add this third-party integration into Shiny with different packages and things, that it does kind of help to know just a little bit of JavaScript, or you don't have to be a JavaScript expert or anything like that, or just have a basic idea of how different JavaScript objects work, because that will give you a lot more control and the ability to do things that maybe the R version or the Shiny version of this tool really, weren't ported over well, or didn't add in. You can go in and really customize things if you have that JavaScript knowledge. Almost all of these tools give you the option of injecting straight JavaScript into your R Shiny code. Here's what, some, again, condensed code for a leaflet map would look like on the server. Again, it is an output object, right? Just like everything else. And here we've got a render leaflet function coming from the leaflet package. And here we can create a map with tiles. We can choose where we are on the map when it appears. We can add layers to our map, such as polygons, give them different colors and give them labels and things like that. And then when we want to add the map to our UI, it's a simple function with an output ID. Another thing that I wanted to talk about when it comes to all of these projects, really not just this one, is that an understanding of HTML and CSS is very, very helpful when you're working with R Shiny. Here's a good example. This is not my app, this is someone else's, of an app without CSS that isn't using CSS, and you can see this sort of awkward layout that we have here, sort of unprofessional looking. And here is that same layout with CSS applied. CSS stands for cascading style sheets, and it's just a way to style, apply stylistic characteristics to the different objects in your user interface. But it makes a huge difference as to not just the look of your app, but also how easy it is for people to understand how to use it. So the tutorial that I provided for the R workshop series, it goes into how to add CSS to your Shiny app, but there's also this tutorial here where these images came from. This is a good one too, if you want to check that out. And so ultimately, this one again was deployed on shinyapps.io, since I wanted anybody to be able to look at it. And if you're interested in that tutorial that I wrote, I think if you have some basic knowledge in R, if you're able to create scripts in R, and you want to start working with R Shiny, want to get used to doing that, I think it's a pretty good tutorial just to get you introduced to it, to give you some practice. So if you go to the R Open Labs website and look at the lessons, you'll find that tutorial under extras. And that's about it. That's about all that I have prepared for today. So if anybody has questions about what I've covered, or even just things that they want to discuss, if it's not really a question, feel free to use the chat or the microphone.
I have a question. This is really great. I see lots of usage of this, and I sort of prompted, I think, today's session with my question. But do you see other uses at your university from the administrative point of view to like create a dashboard for your dean or something like that?
Absolutely. So I will say, as someone who has looked at a lot of different visualization tools, there's a lot of great tools out there for creating dashboards. We have Tableau, which is very popular. There's a Google Dashboards tool as well that can do some nice things. It really depends on what it is that you want to do with that dashboard. And also there's I would say a money component to this as well, an expense component. Tableau does create dashboards, visualization dashboards, a lot more easily and quickly without requiring that you write any kind of code. However, Tableau is an extremely expensive tool. And requires lots of different licenses, and it's a bit more complicated in that aspect, whereas using our Shiny is free and open source. And of course, any dashboarding tool that you use that you're going to be writing from scratch, you're going to be creating with code, you're going to have a lot more control over what that dashboard can do, how it can look, how it can work, than you will with a tool like Tableau or like the Google dashboarding tool. So I would totally recommend looking into that if you want to, for administrative use, absolutely, especially if you want to have really fine-tuned control over what you're putting into that dashboard and how it works. Absolutely.
Hi, Lorin, it's me again.
Yep.
I have another question. It seems like Shiny is for interactive animation, and you do most of your data manipulation still in your local desktop or machine. Is that correct? And do you think there is any differences if you want to upload your data frame for Shiny purpose? The data manipulation is different.
No, actually, so the data manipulation that's done in all of these apps, just to be clear, it is done in R. So Shiny itself goes into an R file. So you would open up an R file, and then you would use the Shiny UI and Shiny server functions to separate the UI and server code. Also, within the UI, well, within the server, really, most people do it within the server, you can use regular R code for manipulating objects like you would in any other use case of just regular R, right? So if for example, in that project where we were, people were submitting the CSV files with their appointments on them, that file would come in, and then there was some code, R code in there to do data transformations, change the column names, move the columns around, that kind of thing. And that was added to the server section of the Shiny code. So yeah, you can pretty much do it all together all at once as in a package deal. Shiny really works on top of R, but it does sort of change the way in which you think about how your code is structured. You need to spend a lot more time thinking about, you know, how you accomplish certain things and when you accomplish those certain things in your script than you would otherwise.
Thank you.
I see some questions here. Okay. I see a dashboard for Dean with various stats so they can get the info out without emails, etc. For example, consultation, Ask-a-Lib, Circa, ILL, etc. Yeah, I mean, there really are endless possibilities. And I think anything that puts dashboards within reach of people is going to be a good step one way or the other. Building dashboards, visualization dashboards, I think accomplishes a lot more than people realize, because not only does it give you access to all that information at a glance, it gives you the ability to visualize information, to explore information, analyze it, interpret it, all that kind of stuff. But it also requires you to take stock of your data environment. where is your data coming from? Where is your data stored? And how are you going to get it together? How are you going to get it to work together? So yeah, dashboards are great, and it would be great if all the administrators at a organization could have their own personalized dashboards, like a dean's dashboard and a provost's dashboard or whatever else. Sorry if I missed this, but do you have a GitHub, or are you willing to share the code for the second project? Yes, I do have a GitHub, and I am willing to share that code. That's something that I can upload. I haven't put that on the GitHub yet. So sorry. Yeah. So yeah, I will do that, and I will send an email out and let people know how they can access that information. I'd be happy to do that.
So one follow-up about the server-based Shiny visualization. Does that mean if it's shared over the server, then it's not for public, and only people in the admin with admin access or with certain kind of authorized access, they can access the dashboard or the visualization?
Yeah, and those sort of things are established, within each server. So whoever is making those choices about permissions, about security and things like that within an organization, with us, it's our IT department. They're going to have those sort of restrictions set up on the server already before our Shiny is brought in. So our Shiny server can only be accessed by people within our organization. And if you're off campus, I mean, you need a VPN in order to access it. And that's the sort of security they decided that they wanted for that server.
I mean, if regular people who don't know how to use R, but they are affiliated, they can still access it in the kind of like a web page style, like what we can see on the regular free Shiny website. Is that correct?
So do you mean like on
Yes, Shiny server visualization, so people access them using the server-based interface, or it can also be applied to a regular like internet web page?
Got it. Yes, you can. If the server is set up for the public to use, then absolutely, you can publicly host Shiny server on a public server. Absolutely.
I probably want to give everyone 1 or 2 more minutes to think about if you have extra questions or comments. And I also want to thank you, Lorin, again for your time and energy to prepare this ISIST webinar, because we are in the same community through email. So it's hard to meet everybody in other scenarios except the conference and webinars. So again, if you have any topics for the future webinars, I hope you feel free to send Sarah or me an email. If you have any questions regarding to today's webinar, feel free to reach out to Lorin. As Lorin mentioned, she will share some codes through emails or GitHub link. And I wish I didn't miss any of your comments or questions. And yes, as Sarah mentioned in the chat box, we will share the recording and hopefully Lorin's slides in our email list, and the recording will definitely be posted on the YouTube channel. So if you missed today's webinar, you can also retrieve in our YouTube channel. Thank you, everyone. And I think this is the end of today's webinar. Have a nice day.
Thank you, everybody.
Bye-bye.
Bye.